Welcome again to this next session, that is second session on quadratic equation. Now in this, what are we trying to do? If we know the roots of the equation, what is written? If we know the roots of the equation, that is quadratic equation. What is a quadratic equation? General equation: ax square plus bx plus c is equal to 0. I have written in the equation form, that is equal to 0. If the roots are, say, alpha comma beta, why did I choose only alpha comma beta? Because in the many textbooks it is followed standard, it is followed as alpha beta, and if I write the same thing, you will not have any confusion. If I know the quadratic roots of the quadratic equation are alpha and beta, or if I say they are the zeros, actually they are what? They are the zeros of the quadratic equation. Then, or even I should say, when I say zeros, it can be for the quadratic expression also. Now quadratic equation can be written as x square minus of alpha plus beta into x, that is the sum of the roots or sum of the zeros into x, that is the coefficient of x becomes alpha plus beta, or not even alpha plus, it is minus of alpha plus beta plus alpha into beta, that is this is the product of the roots, that is equal to 0. Then suppose if I am given with quadratic expression instead, that is ax square plus bx plus c only, then I will call it as zeros of the root, zeros of the quadratic equation alpha comma beta. Then I will write the quadratic expression as x square minus of alpha plus beta into x plus alpha into beta. But wait, is there any relation between the zeros and the coefficients? Yes, see here this is alpha plus beta, but here the quotient of x square is 1, but here the quotient of x square is a. Here the quotient of x is minus of alpha plus beta. Here the quotient of x is b. See, here the constant term is c, but here the constant term is becoming alpha into beta. So let us look at this and more details in the next session. Bye.